Alright, so in this video we go over sets and compound inequalities. So we have already talked about sets in the previous section, in which we covered interval notations or intervals of numbers. Those intervals are actually sets of numbers. For example, the interval 4 to 5 or 4 to 8, let's make this larger. That's the settable number that go from 4 to 8. So in a way, we already have some notion of what a set is. In this section, however, what we do is the two operations involved in sets. In this case, well, the two operations are the union and the intersection. So let's define each of them. So the intersection of sets denoted with this, it's not an N, it's like a cap. It's called a symbol cap. Means it's for the symbol and for intersection. And that's then in this case the intersection of two sets, which is denoted this way. A cap B is a set of all elements in a set in which there are both in A and B at the same time. Whilst in the union of two sets A and B, in this case it's denoted A union B, or A, well, the other A intersection B, A union B. It's the set of elements in which there are A which are in A in B or on both A and B at the same time. Now in this case, well, the word and would imply looking for the intersection, and the word or would imply union of sets. Well, right now this is like a lot of wording, a lot of words, definitions. Let's just see them in action so you can see what we're actually doing. Well, so consider these two sets right here. Let the set A comprised by the elements 2, 3, 4, and 5, and the set B comprised by the elements 4, 5, 6, and 7. Find each of the following. In this case, they're asking us for A intersection B. So in this case, let's go back to the definition of intersection. So again, the intersection of two sets is the set of all elements that are in both A and B at the same time. Well, for example, let's look at one at a time. The number 2. Is the number 2 appearing on both sets? Well, in this case, no. So it's not going to be listed in the set that describes the intersection. What about the number 3? Well, the number 3 appears in A, but it doesn't appear in B. Well, so that's not a number that will appear. Now, if you observe, number 4 appears on both sets. So that's one element that appears in the intersection. And the number 5, it's another number that appears on both sections. And that's about it, because the number 6 appears in B, but it's not in A. And likewise, the number 7 appears in B, but does not appear in A. And that's about it, just the intersection. Now let's look at the union A and the union of A and B. And in this case, let's look at the definition. The union of two sets is a set of elements which are in A, in B, or both sets at the same time. So in this case, what we're going to do is just list them all. Whether they appear on both sets at the same time doesn't matter. We're looking for the union, not the intersection. For example, the number 2 is safe. We just write it down. Appears in A or appears in B. It doesn't matter in which one appears. The number 3 appears in A. It doesn't matter if it's not in B. The number 4, look at this one in this case. Well, 4 appears on both A and B. So, but the thing here is you might want to pay special attention to this part. When you see two numbers as the same element appearing on both of the sets, we only list it once. Right? The number 5 likewise appears on both of the sets, only listed once. And 6 and 7, just list them. And that's about it. Alright. Now let's do operation of sets like the or and but we're using sets that are denoted in a slightly different way. Well, so we are given the following sets. The set A, which is x such that x is greater than or equal -4. Set B, which is x such that x less than 1. And set C, which is x such that x greater than 2. So let's have a look at those. Well, so number one, as we look on the previous section, well, it would be a really good idea to write these down, these sets in the interval notation 4. That's gonna make our work a whole lot easier. All right, so x greater than or equal to 4, that means all the numbers to the right of -4. I meant -4, not 4. So this is the same as saying -4 all the way to positive infinity. And keep in mind, recall that infinity never has the bracket, always has parentheses. The set B, which is x less than 1, well, all the numbers to the left of 1, so that means it's going to come from negative infinity all the way to 1. But in this case, notice, unlike for having the equal, this one doesn't have that equal, so it's just going to be parentheses as well. Recall the difference between these two symbols. For letter C, all the numbers x that are greater than 2, that means all the numbers to the right of 2. And in this case, parentheses for both. Because again, this inequality symbol does not include the equality part. Alright, so now that we have this set, let's do this operation. So A upside down U, B. So in this case, we're looking for the intersection. Alright, so we're looking for the intersection between A and B. So what are we going to do? Okay, so this is going to be our A. This number line will denote A. This number line will denote B. And this third line will be A intersection with B. So what are we going to do in this case? Well, so A, which is all the numbers from -4 to infinity, well, we're going to go to -4 bracket and all the way to positive infinity. Well, I'm going to use one, I'm going to highlight this with pink actually. Use pink to highlight this. All right, this one is going to go all the way to positive infinity. All right. And set B, what did we say about set B? Negative infinity to 1. Well, actually, it would help if we rewrite them again, just so you can see what are we doing and what are these coming from. Negative infinity and 1. So for B, well, all the numbers to the left of 1. However, careful, look at the number 1. It has parentheses, and then to the left. All right, so let's highlight this to the left. All right, let's highlight this to the left. And I'm also going to do this so you can see the direction of the set. All right. So what are we going to do in this case? Well, intersection. So what we're going to do in this case, I'm going to do a sandwich. So suppose or imagine you can grab this piece of pink stripe and put it on top of the second set, the blue one. So that's exactly what I'm going to do. So I'm going to rewrite it. I'm going to draw it again. This one goes to the left, and then to the right, and on the other hand, the other one, I'm just going to copy it. All right. And in this case, well, what are we going to do? So we're looking for the intersection, in other words, and this is key. You might want to write this down. So circle this. This symbol means, again, intersection. In other words, the overlaps. And I use these colors on purpose because I think the overlap is really easy to see. If we combine pink with blue, when we put them together, this is going to give us a very cool shade of purple. So in this case, the intersection between A and B, it's going to be the purple part, which in this case it's going to go from -4 all the way to 1. So we need to write this down using interval notation. Recall, this is what we did in the previous section. Represent this using interval notation. Just put it in here. All right. Actually, the instruction do not state to write this using interval notation, but most likely that's how it's going to be on the homework. All right. So, and at the same time, this helps us practice doing these intersections. Let's go over another example. Well, so we're going to do another intersection problem, but in this case, it's going to be between A and C. So the first number line will be the set A, the second will be actually C, and then the intersection between A and C. And let's write them down. If you look at the top of the page, A again is -4 to infinity, and C is in this case 2 to infinity. All right, so let's draw these sets. So from 4 to infinity, -4 to infinity, well, that's what we're gonna have. I'm gonna use pink for this. And yeah, I don't know, maybe you can hear my cats in the background. And number 2, in the set C will go from 2 to infinity. I'm going to use a different color in this case. All right. So what are we going to do here? Well, I'm going to put this pink one on top of the blue. I'm going to put them together. I'm going to sandwich them again. This symbol, this sort of an N means intersection. So I'm going to do that's set A, and then parentheses, be careful. So when you write parentheses and bracket, be sure they look like brackets, and by having sharp corners here and these really curvy, so they look like actual parentheses. So I'm gonna put this one. So now what are we looking for? Well, so in this case I'm looking for the overlap. And the overlap, guys, is going to be comprised by 2 to infinity. All right, so 2 to infinity. Those are all the elements that they have both in common when they overlap. All right. Let's do another example. The intersection between B and C. So this is B, this is C, and this is B and C. All right. So let's recall that B is -infinity to 1, and C is 2 to infinity. So we're going to figure out what the intersection between these two is. Well, let's see what's going to come out of this. So -infinity to 1 means from 1 to the left. Let's highlight. And the set C, it's going to go from 2 to infinity. So it's going to go to the right of 2. Now, something really interesting is going to happen here. Well, you will see. So, when I put this together, see what happens. Well, to the right, to the left. Well, in this particular case, if you notice, well, we're looking for overlaps. In other words, in terms of colors, we're looking for something that looks purple like this. However, nothing in this case intersects. So what's going to happen here? Well, how are we going to denote this? Well, there's two ways to denote this. Number one, curly braces with nothing inside of it, which means empty space because there's nothing intersecting. The other option is, and you might see any of these two when you do the homework, it's like an O with a diagonal like this, which means empty space. All right, now let's look at other cases, at the next case with union. So let's see what's this gonna be about. So let's do B and C again, just like the previous case. We're gonna look for B union this time and C. All right, so let's write this down. And so B, again, this is a negative infinity to 1, and C is 2 to infinity. Let's find out what this is. Well, so for B, which is negative infinity to 1, it's going to go in this direction. For C, it's going to go from 2 to infinity in that direction. Nothing different as in the previous one. All right. So now let's put this together. But before putting this together, let's shade them so you can see the colors. And that way it would be way easier to visualize what's going on in here. Well, let's put them together. On the one hand, it goes this way. On the other hand, it goes the other way around. And it's going to go blue over here. And it's going to go pink this way. Well, in this case, we're looking for the union, not the intersection. So we're not looking for purples here. We're not looking for overlap. So we're looking for the elements that in this case belong to either this guy or the other guy. All right, so how are we going to denote them? Well, this is negative infinity to 1, and this one is 2 to infinity. Well, all we do is simply write them down together. Negative infinity to 1, 2 to infinity. In the middle of it, we are going to put a union symbol. All right? Because we're looking for the union. We're connecting this together. These two guys are being connected together. Let's do another one involving union. So between A and Z. A union C. Let's see what's going to come out of this. Well, so in this case, A from negative 4 to infinity. And from C, it's going to be 2 to infinity. Let's see what about the unit is going to be here in this case. Well, so A, which goes from negative 4 to infinity, and we already did this one again as well, but this time we're gonna look for something different, not the overlap, but actually the union of them. So let's shade. All right, and let's put them together, one on top of the other one. Negative 4, and in this case, this is what it's gonna be. So now need to be very careful about how do we interpret this case, because we're looking for the union of these two sets. And the example that involved this kind of shading, which is actually the previous page, we were looking for the overlap for the purple part. In this case, we're looking for all the elements that are in either A or C. That is this whole thing, this including, so in other words, we're looking for the elements that are in either pink or blue or both, which is the purple in this case is this whole thing. So how are we going to, well actually let me, this A. So it's going to go from -4 to infinity actually, and simply -4 to infinity. And that's the final answer. Alright, let's look at letter F. So for letter F, A, B, A union B. What's going to be about it? Well, so A, again, recall that A is -4 to infinity. And B, in this case, is -1 to, negative infinity to 1. All right. So let's put these two together. Well, let's draw them. And in this case, what's the other set? Well, 1 to negative infinity to 1. That's going to go with blue. All right, so let's put the line just so it looks like, to give a sense of direction here. Let's put them together. Let's do the sandwich here. So now, when we do this, well, we already did this at the beginning, but now it's going to look different. So, well, it's going to look the same, but we're going to look for another piece of information here. All right. So, well, in this case, what are we going to be looking for? Well, so we're looking for the union of these two sets. So we're looking for all the elements that are in either blue or pink or both. That is, in this case, well, the whole thing. Well, but I mean, we cannot just write that, the whole thing, just like that. We need fancy way to denote it. Well, in this case, all real numbers, negative infinity to positive infinity. This means the whole thing. All right, well, so let's move on to the next topic. Well, the next topic is to solve compound inequalities involving OR. Well, so right here in this green box, you will see the steps for solving compound inequalities involving OR. Well, we need to solve two separate inequalities and then find the union of both, just like we did in the previous couple of pages. That's coming back. I'm glad we're practicing some of those to prepare you for the next type of exercises. And then express final answer using both set notation and interval notation. Mostly we would do interval notation, but I'm gonna actually do both of them. Well, so what do we have here? Well, solve each inequality, compound inequality, and graph the solution set. Also express your final answer using both set notation and interval notation. So let's see. So I'm going to solve this inequality first. Well, so I need to get x by itself. What I'm going to do is add 5 to both sides to get 3x. The 5's cancel, less than positive 5 minus 2. That's going to give us 3. And then I'm going to divide both sides by 3 to get x by itself. And x equals, not equals, actually less than 1. So that's the first inequality. All right. Let's do the second inequality. So the idea is to get x by itself. So let me subtract 4 over here, actually on both sides. Cancel the 4's. That's going to give us negative 5x less than or equal negative 16 minus 4. Be careful with all negative signs. That's going to give us negative 20. And then we need to divide both sides by negative 5 to get x by itself. But be careful here. Recall from the previous section that every time that we divide by a or multiply by a negative number in an inequality, we need to reverse the inequality signs. And then negative over negative is positive. 20 over 5, that's 4. So in this case, we are solving x less than 1 or x greater than 4. So in this case, this is what I would like to do. I'm going to give letters to this set. Let's call this A, and let's call this set B. So over here, we're going to have A, B, and then for OR, we're looking for the union A union B. So let's solve this inequality. Let's put this together and shade then put together. So all the numbers of x that are less than 1, well, like this. And then I'm going to actually shade this way, right? And then for set B, what do we have? Well, x greater than or equal to 4, we go from 4 and on. All right, so let's see. Let's put these two together. On the one hand, all the numbers less than 1, and on the other hand, all the numbers greater than 4. So that's what we have. This way, that way. All right. Let's see. So we're looking for the union. So all the elements that are either here or here. All right. So in other words, this is negative infinity to 1. And this one is 4 with bracket to infinity. So all we need to do is put these two together with a union symbol. So negative infinity to 1 union 4 to infinity. And that's the final answer. So when you do the homework to this, what you most likely what you will be asked for is most likely some kind of a multiple choice with a union of the two sets, and then type this in a blank space. Let's do another example. 3x greater than or equal 7x plus 8 or x less than 4x minus 9. Well, in this case, when it comes to having something like this, again, keep in mind that you want to have all the x's, or well, all the variables on the left hand side and all the pure numbers on the right hand side. So I'm going to subtract 7x on both sides. And then 3x minus 7x, that's a negative 4x. Greater than or equal 8. And then I'm going to divide both sides by negative 4. But what's going to happen, remember, every time we multiply or divide both sides of an inequality by a negative number, the inequality sign reverses. So that's the first set, x less than or equal to 2. Let's do the same over here. So I'm going to subtract 4x on both sides to get this cancel. And x minus 4x, that's a negative 3x, less than negative 9. And in this case, I'm going to divide both sides by -3. And x is going to be greater than 3 again, because we divide both sides by a negative number. We need to reverse the inequality sign. And negative over negative is positive 9/3, which is 3. So this is going to be our set A, and this is going to be our set B. And we're looking for OR. All right, so I'm going to have set A over here, set B over there, and on the third one, the union of both. All right, so where's my, here it is. So A, all the numbers to the left and equal to -2. All right, and x greater than 3. All right, so let's shade this to the left, to the right. All right, and -2 and 3. And just like we did in the previous example, we're going to look for the union of these two sets. Notice we're not looking for overlaps. Recall that OR implies union, and union does not imply overlap. All right, so let's see. So in this case, let's use intervals to represent each of these two. The pink one is going to go from -infinity to -2 with a bracket for -2, parentheses, always for infinity symbol. Over here it's going to go from 3 to positive infinity, 3 parentheses, union, not union, actually all going all the way to infinity. So the union of these two sets is going to be these two. Okay, let me actually denote it again. It would be a good idea if I do it over here as well. A union B. These two sets together, -infinity to -2, 3 to infinity, connected by a U symbol, which is the union, the notation for the union of sets. All right, let's do one more example on the next page. So in this case, well, let's look at letter C. We might be in the need of getting rid of those parentheses. Well, what are we supposed to do when we have something like that? Well, use the distributive property. You guessed that well, if that's what you were thinking. So 6 times x, that's going to give us 6x, and 6 times -2, -12 less than 12. And over here, 4x plus 4 times 3, that's 12, greater than 12. All right, well, so let's solve each of these individually. So let's add 12 to both sides to get 6x less than 24, and then divide both sides by 6 to get x less than 4. All right, so that's our first set. In the next set, we're gonna do the following. Well, so subtract 12 from both sides. That's gonna zero these 12s out. So 4x greater than 0, and then divide both sides by 4. What are we gonna have? Whole, in this case, x greater than 0. So again, it's a good idea to label this as A and B respectively. And don't forget that we're doing an OR operation. We're looking for the union of two sets. All right, so that's that being said, let's go to the number lines in which we are going to graph these two little sets? Well, all the numbers less than 4. So I'm going to go 4 in parentheses, but pointing to the left. Because it's all x less than 4. Actually, the inequality sign, again, recall that this gives you a sense of direction. It's like an arrow pointing to the left. While in this case, x greater than 0, we can sort of see an arrow pointing to the right of 0. So we go from 0 and on. All right. Let's do some direction here. And let's shade. Now let's put them together well. So to the right, to the left. So to the left it's going to go with pink, and to the right it's going to go blue. And in this case, well, we're looking for the union, which in this case, the union by definition, it's all the elements that are in either A or B or both. In this case, that's the whole thing, which in this case is negative infinity to positive infinity. All right. Let's move on to a different kind of inequality. So now we're going to solve compound inequalities involving ends. And the process will be exactly the same. However, instead of looking for the union of the sets, that is the union of the colors or the connection of the colors, we're going to look only for the overlaps, that is the intersection. So again, keep in mind, intersection, that's simply a fancy word for overlaps. You can think of it as that, overlaps. All right. Okay, so how about we do an example? Of course. So let's see. So 3x plus 2 greater than negative 7, and no longer or, in this case it's and. 4x plus 1 less than or equal to 9. So let's subtract 2 to both sides to get 3x greater than negative 9, and let's divide both sides by 3. Should we reverse the inequality sign? And in this case, if you were thinking, no, you were right, because we're not dividing by a negative number. We're dividing both sides by a positive number. So that's our first set to actually to graph. All right, so let's see. What about B? Let's do the same. Solve the second inequality. Subtract 1 to both sides of the inequality to get 4x less than or equal 8. And then divide both sides by 4 to get x less than or equal 8 over 4, which is 2. And in this case, again, we keep the same inequality sign because we're not multiplying or dividing by a negative number. Again, as usual, this is A and this is B. But don't forget that in this case, we're doing an and operation, no longer an or, in this case an and. Now, A, B, A and B. Let's put these two together. Right, let's put those two together, and then x greater than negative 3, I'm going to go to negative 3, and then I'm going to go to the right. With parentheses, of course. All right, because it only has greater than. But in this case, x less than or equal to, the direction of the tip is going to the left. I'm going to go to the number 2. But in this case, with brackets, because we have the equal part, as opposed to the other set. So let's put these two together. but not before shading first. Alright, so let's put these two together, and this is gonna go pink to the right and blue to the left. Alright, well, in this case, for the and, oops, no, that's not what I meant, A and B, we are looking for the overlap between A and B. The overlap, again, it's going to be the shaded part covered by the purple part, which in this case goes from -3 to 2. So simply -3 with parentheses, comma, 2 with bracket. Final answer to this. Final answer. Alright, now let's move on to the next example. 2x plus 4 less than 8. So let's solve each inequality individually. Subtract 4 to both sides to get 2x less than 4, and then divide both sides by 2 to get x less than 2. Alright, now let's look at the other one. Subtract 5 to both sides to get, be careful with signs here, negative x less than positive 4 actually. 9 minus 5 is 4. Now in this case, to get x by itself, we need to divide both sides by -1. But doing it so, what's going to do? Reverse the inequality sign. And what's going to happen here? Well, as usual, let's see. This is going to be A, and this is going to be B. So A, B, A, union, B. I mean intersection, not union. I meant intersection or overlap. So all the numbers to the right of 2. So I'm going to go to the number 2 because of the inequality sign. It's going to go this way with parentheses only. For x greater than -4, I'm going to go to -4 with parentheses only and to the right. Look at the direction of the inequality sign. It's pointing towards the right. And let's do the usual shading. Okay, so that's 2, -4. Let's shade the one side, shade to the other side. And we are going to do exactly what we were doing with the previous example. Well, some part of this shading became, or actually turned purple, because the combination between pink and blue is purple. So in this case, we're looking for that part which is -4 all the way to 2. So the intersection A and B will be -4 to 2. All right, let's look one more example, and we're almost done with this section. Well, we're gonna have a similar case as the one that we were doing in the OR example. So what we do essentially here is, yes, you guessed it right, we need to do distribution here. Well, so 6x minus 2, that's a 6x minus 12 less than -18. And let's actually, so I'm gonna run out of space here. I'm gonna need more space. Let me do that again. So that's a 6x minus 12 less than -18. And for the second part, that's for x plus 12 greater than 12. All right. That's not looking like a 12. So I need to subtract 12, actually add 12 to both sides to get 6x less than negative 6. And then divide both sides by 6 to get x less than negative 1. And that's our first set. Let's look at the second set. Subtract 12 to both sides to get 4x greater than 12 minus 12. That's a 0. And divide both sides by 4 to get x equal, not equal actually, x greater than 0. 0 over 4 is 0. Label these two, a and b. So AB, A intersection B. Again, recall that we were doing an AND operation. Actually, I didn't put the AND for the previous one. Let's put it back in. So what are we going to do? Well, graph this set. So for the first set, which is A, I'm going to go to the number negative 1 and then point to the left of it. For the second set, I'm going to go to 0 and then point towards the right of it. And let's use the same colors to represent each of these two sets. All right, so let's see. We're going to put these two together. And what we're going to look for is the overlaps. However, I think you are already envisioning what's going to happen. All right, so ultimately when we look for the intersection of two sets, what we're looking for is the overlap of this. So in other words, what we're looking is for the purple part of it. But in this case, if you look at these two sets, they do not intersect. There's no intersection between the two. So we simply say empty space, or remember the other alternative, curly braces with nothing inside, like an O with a diagonal cutting it into. Alright, so we're going to solve compound inequalities involving AND, but what I'm going to call type 2. The other one was called type 1, because in this case, well, these are actually broken into the two pieces. The compound inequalities, in this case, type 2, they look more compact and they're actually way shorter to solve in this case. All right, so well, in this case, it's gonna look like an inequality with 1, 2, 3 sides: the left hand side, the middle side, and the right hand side of it. Alright, so our ultimate goal when it comes to solve this kind of inequalities is to have x by itself in the very middle of the inequality. Let's go ahead and do a couple of examples to see that in action. Well, so let's solve this inequality. So our goal is to get this x by itself in the very middle. So this is what we do. Subtract 6 on the 3 sides of the inequality. That's going to give us a 2x in the middle that's greater than or equal negative 6 and less than 8. So the way we read these inequalities, so I'm going to give you the incorrect way to read this. 0 less than or equal to x plus 6 less than 14. That's not the right way to read these two inequalities. The way we read this actually is 2x plus 6 greater than or equal to 0 and 2x plus 6 less than 14. Alright, so let's keep solving this. So all we do is divide the 3 sides by 2. So this is going to be -3 less than or equal x less than 4. And that's about it. That's about it. So that's the inequality we end up with. And well, in this case, we need to write this down using interval notation. Solution set. This will be -3, 4, and just put the corresponding grouping symbols, in this case brackets because of less than or equal, and in this case parentheses because simply less than. Now, how is this going to look like in a number line? So if 0 is right in the middle, typically, well, that's going to be 3 to 4. And all we do is simply shade. In this case, I'm not going to do colors. That's simply -3 to 4. Okay, I'm going to put the 0, make it look like over here. All right. And yes, see how in this case these are way shorter to solve. Let's do another example. Well, this madness contains fractions, and what you might want to do first is get rid of those denominators. How do we do that? Well, by multiplying the three sides of the inequality by the LCD, in this case, multiply by 3. So 3 times -4, that's going to give us -12. And then when we multiply in the middle, these 3's are going to cancel. That's going to give us simply 4x minus 3. And 3 times 3, that equals to 9. And well, let's keep solving just the same way we did in the previous example. Add 3 to the 3 sides, not to both sides, but actually the 3 sides in this case. And that's going to give us 4x in the very middle. And that's less than 9 plus 3, that's 12. But greater than or equal, that's a -9. And finally, what we do here is, well, divide just the 3 sides by 4. And that's going to give us x in the very middle. That's less than 3 and greater than or equal -9/4. You might want to leave it as -9/4. That's fine. So in this case, solution set. Simply write down these two numbers just the same way we did it in the previous section when we changed from inequality notation to interval notation. Remember, that's exactly what we did here in the previous example as well. So that's going to be -9/4, comma 3, brackets for the lower and parentheses for the upper one. And all you might want to do here is, well, put it together. You don't have to be exact right here, as long as you have some good number sense. Well, 9/4 is somewhere, -9/4 somewhere there, and 3 is somewhere here. And from there, just shade. All right. So this is the end of this video. I'll see you on the next section.